In this 10th lecture of special relativity, we introduce the shrinking and slowing down factors. We first recall that events that are simultaneous in one inertial frame, they're not in another frame that moves with velocity v with respect to the first. We then consider the thought experiment that looks at how time is measured by moving clocks. As in the previous lectures, we made use of two frames, the train frame and the station frame, one moving with respect to the other. We first calculated how two clocks at rest in the station frame measured the time delay between two simultaneous events in the train frame. Then we consider the same experiment observed in the station frame. We define the proper length of an object as its length measured in an inertial frame where the object is at rest. By symmetry reasoning, we could relate the ratio of distances between the two frames. By manipulating the equations obtained so far, we finally calculated that the length of an object appears shrunk when measured in a frame where the object is not at rest. Specifically, this is shrunk by a factor s, called a shrinking factor, with respect to its proper length. Similarly, we were able to quantify the time intervals measured by a clock. A moving clock slows down by the same factor s, in this context called slowing down factor, compared to the time measured by the same clock at rest, called the proper time. In summary, length contract and time dilate by the same factor s, which is function of the velocity, with respect to the proper length and the proper times.